Find the form of the particular solution using the Annihilator method to the differential equation y triple prime minus 3y double prime plus 4y equals x times e to the power 2x. So even though it's asking for a particular solution, we'll have to take a look at the homogeneous equation. And so we're going to take a look at the auxiliary equation. The auxiliary equation is r cubed minus 3r squared plus 4 equals 0. And this is a cubic equation. We don't have a formula for that. So we're going to try a couple of values. We could try 1, and then you get 1 minus 3 is negative 2 plus 4. That's not equal to 0. But then if you try negative 1, you get negative 1 minus 3. So that's negative 4 plus 4 equals 0. So what we see is that r equals negative 1 is a solution. And so that means that r minus minus 1 or r plus 1 is a factor. So we would then use long division, and we would factor that out. We get r plus 1. And I will not do the long division here, but what you're left with is r squared minus 4r plus 4 equals 0. And that is something that factors as follows. That's r minus 2 times r minus 2. So we've factored this completely. And so now we see we have r equals negative 1 is a root, and we have r equals 2 with multiplicity 2. And so the basic functions for our homogeneous solution are c1 e to the power negative x plus c2 e to the power 2x. And then when you have a repeated root, you add in powers of x. So that's c3 x e to the power 2x. Okay, so that is our auxiliary equation right there. And now let's take a look at this differential equation, and let's take a look at what is the annihilator for the right-hand side. So when you look at the right-hand side, it's of the form x to the power k times e to the power rx, with k equals 1 and r equals 2. So when you use that, you find that the annihilator is d minus 2 squared. And by the way, you can go to D2L, and there's a list of annihilators that list in one of the previous videos on page 1. That is something that I will make available to you on the final exam, and you may use that on exam 3 as well. So that's the annihilator. So let's take a look at our differential equation. We have d cubed minus 3d squared plus 4 acting on y of x equals x e to power 2x. And now I'm going to apply my annihilator on both sides. I'm going to apply A here and A here. So on the left-hand side, I get d minus 2 squared. And then I'm going to write this in its factored form. So that's d plus 1 times d minus 2 squared. And that's acting on y of x. And then my right-hand side is just 0. And then, of course, I can simplify that a little bit. I get d minus 2 to the power 4 times d plus 1 acting on y of x equals 0. And just as before, we're going to take a look at the roots. This root is 2, and it is a root of multiplicity 4. So I don't just get e to the power 2x, I get x e to the power 2x, I get x squared e to the power 2x, and then I get x cubed e to the power 2x. Okay, so that's the d minus 2 to the power 4, and then the d plus 1, that's a root r equals -1. Multiplicity is just 1, so I get e to the power -x. So I have 1, 2, 3, 4, 5 functions that will be part of my general solution. So let's take a look at which of these are part of my homogeneous solution. So that's e to the power -x. So that's part of yh. And then I have e to the power 2x, and then x e to the power 2x. That's all part of my homogeneous equation. So I can write that down as I did before, c1 e to the power -x plus c2 e to the power 2x plus c3 x e to the power 2x. But the parts that are new, so this, sorry, I'm writing down the general solution. So this is y of x, and I started writing down the first part of that. That's yh of x. And then the second part, that's the particular solution. That's x squared e to the power 2x plus, and that's then a c4, and then plus a c5 x cubed e to the power 2x. And this is part of my particular solution, or that is a particular solution to my differential equation. So the most general solution to this problem that we were working on is given by this here. And again, if we wanted to fully do this, so the form of the particular solution is just this green part. But if we wanted to write down the complete general solution, we would have to plug this in to the differential equation to figure out what C4 and C5 are. But this question only asks for the form of the particular solution, which is given by this. So once we find the homogeneous solution, we apply the annihilator, and then we solve another homogeneous equation, and we just keep track of what we already found and then the new part. And just to get an appreciation, I've repeated here the method of undetermined coefficients. And so you can try to solve this problem using the method of undetermined coefficients. And hopefully you get some appreciation for the Annihilator method.